I have here what's called the periodic round table. I got it off eBay and it came with this little card that it kind of explains its shape. So if you start off with the normal periodic table, the only real change is the move of helium over to the alkali earth metals. And it says it's justified by the same electron configuration. But anyway, the rest of it is just moving whole blocks around. So you move the two alkali metals and alkali earth metals clear over to the right, take your lanthanides and actinides and swing them over to the left. So all the numbers still go in order. It didn't really change anything. This is a perfectly useful periodic table. It just doesn't show some of the patterns of electronegativity as well, so that's probably why it's not as used as much, but it's still kind of a neat form, I think. But the reason it has the shape it does, or the wooden one does, is if you'd wrap this up, it'd kind of give you something like that right there. And if you transfer that onto wooden blocks, you're left with a shape like this. And all the information of the normal periodic table is still there. All the groups are still in the right order. So for example, we've got neon, noble gas, argon and noble gas is right below it, krypton's right below it. So what's below krypton? Xenon's right below that, and then radon should be below that, and it goes on down. The filling order, well, it goes 1, 2, and then 3, 4, and then so 5, 6, 7, 8, 9, 10, and it fills in the middle. And so we ended on what? 12, so it starts 13, goes around in the middle. Then it does the same, keeps filling in clockwise, jumps to the next level, then fills in the middle. It does that all the way down. The individual wooden discs, so one of these is a period, and the set of two of them that are the same size are called a tier. And each of the elements takes up the same amount of space. That's something kind of weird. I'm not quite sure how it works out as good as it does, but it works out. So hydrogen have the same area as zinc or any of these other ones. All of the elements have the same area. And each of these disks, or each of the tiers, is increasing in size by the diameter of this top piece. So it's increasing, you can see, by 1 diameter each time for each one. And this is the formula that allows you to calculate how many elements are on each period or each tier. So we take the let's do this top one. So we take the tier number, so we're on tier number 2, so 1, 2, or we square that, so that gives us 4 times 2, that gives us 8. So that gives us 8 elements on the period. So there should be 8 elements on this period. 1, 2, 3, 4, 5, 6, 7, 8, and there is. And then to figure out how many elements are on the tier, you can do it this way. Take the tier number. So let's do number 1. So tier number 1 times 2, that gives us 2, and then square that gives us 4, so there should be 4 elements on these 2. So 1, 2, 3, 4. And this works for any of these. I won't do it right now because I kind of need a calculator to do that math in my head, but it works out for all of them. One of the things that is kind of interesting, I was trying to figure out why it has that relationship and what you can do with it, and what you can do is you can calculate what element lies below any of the other ones. So for example, we're pretending we don't know what lies below neon. So to figure that out, the element we want to know about, we need to figure out what tier number it's on. So we want to know this one right here. So it's on tier number 1, so it's on tier number 2. So we square that. 2 times 2, that gives us 4, times 2, that gives us 8. So then the thing you do is you add that number to 10, the number that's right above what you're trying to figure out. So that gives us 18, which is argon. Not sure why this one doesn't have an R on it. It's supposed to. So we want to know what's below argon. So we're on tier number 3 now. We want to figure out what's on tier number 3. So 3 times 3 is 9, times 2 gives us 18. 18 plus 18 is 36. Krypton, number 36. And you keep on going down as far as you want on any of the elements. So it even works on element number 1. So 1 times 1 is 1 times 2. Gives us 2 plus 1, that gives us 3 lithium. So let's figure out what lies below lithium. So we're on tier number 2. 2 times 2 is 4 times 2 is 8. So 8 plus 3, it's 11 sodium. Yes, and that's right. One other thing is you can figure out how many elements are in each ring by this formula right here. So the ring number away from the center, so 1, 2, 3 times 4, so 12 minus 2, that gives us 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that even works for the middle one, so it's 1 times 4 minus 2, that gives us 2. So 1, 2, or the second one, 2 times 4 gives us 8 minus 2, that gives us 6. So 1, 2, 3, 4, 5, 6, and that works for any of them. Let's see, what was the other thing? Oh, yes. I don't quite understand it, but apparently these are called the principal quantum numbers. So S would be a stand-in for 0, P for 1, D for 2, F for 3. And the odd thing is, if you add these together, it gives you the number, the period number, so the number of disks from the top that it is. So 1, 2, 3, 4, 5, 6, 7. So all these should add up to 7. So 7 plus 0, 7, 6 plus 1, 7, and so on. And I'm not quite sure the significance of that. I don't have enough understanding of chemistry to know too much about that. So anybody that knows why it would be like that can comment and let me know. What else? Oh, these bottom 2 rings are what I made the original set and on element 120. So I just kind of extrapolated and went with 121. You know, I just took the same pattern and made it go with these 2 disks here. So this one starts in 121, ends in element 170, 171 to 220 on the second one. No, it's probably not terribly practical because some of those heavy elements are going to have very different properties. But anyway, it was kind of neat just to extrapolate the pattern that was going on here and to figure out what elements those should be down there. But anyway, that's the periodic round table.